Okay, this question is a little complex because it's a lot of algebra, but it's hard to get interested in this, but if you understand it, then it's actually pretty cool. You feel pretty good about yourself. So, to start with, part A. Suppose an investment for k days has a continuously compounded interest rate of r. So, just beforehand, we know when we're dealing with continuously compounded interest, we use the number e, and we put it to the power of delta being the interest rate, and we'll multiply it by some time amount. So whatever. So this time amount is the amount of periods that we're going to be compounding. So if it was, say, annual and we're compounding it 2 years, then the interest rate would be in a per annum type thing. If the interest rate was half yearly, then we would be compounding, of course, 4 times for 2 years. So basically for this question, we're not looking at it like that because they want delta to be replaced by the letter r, which is fine. So e to the r times some time period, and over here the time period is k, days, and we're assuming that there's 365 days in a year. So k over 365. Okay, and that's going to equal, so we've got to find I, the equivalent simple annual interest rate. So it's going to essentially equal the simple interest formula. And just with this bit, with the number e, I actually had a bit of trouble trying to find out exactly how it works, the details of it. I've always just used it, but it's really cool. The best explanation I've found has been on Khan Academy, where if you look up simple interest and the number e, it explains it probably the best I've ever found. And now I actually really understand this whole concept of continuously compounding interest. So highly recommend checking that out. Okay, so for simple interest, we're going to be using 1, which will be that principal amount, plus some interest amount. So it'll be some interest amount I times the time period, being k over 365. And all the question wants to know is, what is I? So we just have to transpose this to give us I. So we'll first minus 1. So we can have E R K on 365 minus 1 is going to equal I times K on 365. And then all we have to do is just divide it by K on 365. So when we divide, we flip it over. So all I'm going to do is this, and I'll remove this bit here, so I'll skip this step in the working, and it's going to be 365 divided by k. And you can write it however you want. You can extend it out and say the whole thing divided by k, whatever. Anyway, that's what I equals in this case. So if you want to write it on your test or whatever, that's how you would do it. Okay, all good. So that's that. Now, part B. Suppose an investment for k days is quoted as having a simple interest rate of I. What is the equivalent continuous compound rate? So it's the exact same question, it's just in reverse to the other one. We're using this bit over here, all of that, and instead of finding I, we're trying to find R. Okay, so all we have to do is to get rid of this bit over here, we'll take this bit, 1 plus I times k over 365, and we'll put it to the power of the inverse of that. So it's going to be 365 over k. And I'll just get rid of those 2 dots, 2 lines. I thought it was useful before, but now it's not. And that's going to equal e to the r. And now to get r by itself, all we have to do is find the log of all of this. So the natural logarithm, because it's got a base of e, so it'll make this become 1. So we'll do it like this, 1 plus I times k over 365 to the power of 365 over k, and that's going to equal r, because log of e of r, you plug it, so you can bring r there, so it's r log of e, and ln of e equals 1, so it's r. And so we can also plug this, which is a rule. So we can take this bit, and we can move it out the front. So r is going to equal 365 over k multiplied by, multiplied by, as in it is multiplied by, but it looks better like this. We can still keep the times there. ln 1 plus I times k over 365. So that is what the continuously compounding rate is with respect to the simple interest rate, I.